Hello guys, so for this week we're going to look into resumable uploads, another interesting problem. To achieve this, we're going to implement a server that supports uploading files in chunks instead of all at once, so that if an upload fails, we don't have to re-upload the entire file again. Let's get right into it. So to get this to work, we're going to use a HTTP feature called range requests. So a range request asks a server to send only a portion of an HTTP message back to a client. So we are going to use this, but not for this functionality. What we are interested in is the range request header. So for example, if you look at this content range header here, it says that you are sending 0 to 50 bytes of 1270 bytes in total. So the complete file size is 1270 bytes. And you're sending 0 to 50 bytes. So your server should be able to use this information to keep track of the file you're uploading and be able to combine those chunks that you're sending to it into one full file after you have sent the 1270 bytes that you're supposed to send. So you're going to implement something that uses these headers to keep track of the upload chunks. So you're going to use an express server to implement this upload functionality. So as a start, let's jot down what you want this server to do. So the first thing is it's going to receive a file upload, and then the next thing is we are going to inspect the range headers and then determine the chunk being sent, and then we need to save chunk to temp file, and then once complete, we need to combine the chunks into one file and then move the files to the upload dir and then delete the chunks. So let's start with the first step of receiving the upload. So we are going to receive the upload in say the upload endpoint. So let's add it. So up.post upload. So I don't want to handle the file upload logic manually. So we need some sort of middleware that will just clean up everything and give us the file at the end. So what I use for this is an npm library called busboy. So let's add it. So ban add busboy. So let's require it. Var busboy is equals to require busboy. So don't mind that I'm using require statements. I'm not in the mood to set up ESM for now because it's really a pain to set up. So we're just going to go with the require statements. So let's initialize it. So var busboy is equals to new busboy with the headers passed to it, and then we attach the request object to the busboy object, and then we add an event listener that will receive the file. So busboy.onFile, we get the field name and then the file and then the file metadata. So this should be enough for us. So we now have the file. So let's move these next steps inside our file here so that we can follow through with them. So the next step is to inspect the range headers. So to process a file, there is 3 headers we need. So the first header we need is the chunk size header. So we need to know the size of the chunk that is being sent. So our chunk size equals to request.headers. Let's call it let's call it chunk size. And then another header we can have is say the file ID, so that each upload has a unique file ID that we can use to save the file. And then finally we can get the range headers via the content range header. So the content range header will look something like this. So it will have a start byte and then an end byte and then the total number of bytes overall. So let's create a util that can be able to pass this header into a start, an end, and a total value. Let's call it pass range. So it will receive a range and then pass those values. So the bytes look something like this. So bytes, then there's a space, and then 0 to 99, for example, over 1000 bytes. So the first step is to remove the bytes text with the space. So we are left with the range and then the total one. So we should split them into 2 according to the /. So that means we have the range parts, which now have a start and an end. And then the total is the rest of this part. And then you can return the start, the end, and the total. So just for clarity, let's type this function. So it will receive a string, so passes a range header. It will be something like bytes 0 to 99 to an object. So it returns an object with a start, an end, and a total value. So this is the content range header, and then the range will be the passed content range header. So that finishes this. So let's go to the next step of determining the chunk that is being sent. So the part that is being sent will be the range.start divided by the chunk size. So for example, if the start range is 3000 bytes and the chunk size is 1000 bytes per chunk, that means you're on the third part of this chunk. So that's what this means. So with this, we'll be able to determine on which part of the chunk we are. So we can use this part to generate the file name that we're going to save this chunk in. Let's import the utility and also the fs utility, because you're going to use both of them. I don't know if you're going to use the path utility, so let's just import it also. So path is equal to require path. Okay, so let's save the chunk to a file. So let's generate the file name for this part. So the file name will be determined by the part we are on. So it will be the number we are on dot part, and then we pass the part there. So this will be something like 0.part, 1.part, and so forth as you're saving the files. So how are we going to save this file? So you also need to save this to a folder, to a temp folder. So var tmp dir name should be util.format. So you're saving it to the tmp dir on this server, and then should be the name of the file. So each file gets its own directory. Yeah, let's log this. So console.log the temporary dir name, and then you can also log the part file name. Let's make sure that these directories exist. So if it doesn't exist, let's create the directory, and because it's more than one directory, let's make this a recursive call. So let's save the file. So our part file path should be the temp dir name plus the part file name, and then we can create a write stream for this part file path, and then pipe the file that is being sent to this stream. So the uploaded part will now be saved to our part file path. That looks good. So once the file has been saved successfully, we can respond with a success message. You can just send an OK message. I think this should be all. So I think before we go on to the rest of these 3 steps, let's test if this is working. So we are going to generate a file that we can use to test this upload endpoint. So to make this easier, we can save it in a bash script. So let's call it upload.shell file. So let's open this. So what we want to do is generate a 10 MB file, for example. So we can use the dd utility to do that. So what this dd command does is it generates a 10 MB text file called 10mb.text. It's just a file that is filled with nulls, but it will be 10 MB in size. And the block size is 1024 bytes, which is 1 kilobyte. And then we're generating 10,240 blocks. So 10,240 blocks times 1024 bytes per block will be 10 megabytes. So that's what this command does. And then we want to upload this in chunks of 10. So chunk into 10 parts. So you can use another Unix utility called split to split into 1 MB parts in this 10 MB txt file. This again will generate 1 MB chunks of this file that we'll use to upload. So let's just run this command as it is so that you can see the effect. Or so that we don't corrupt our working area here, let's move this upload script to maybe a tests upload.shell folder, and then we can move to the tests folder, and then we can run it so that you can see what is generated. So you can see that a file called 10mb.text was generated. If we check the size of this file, you can see that it's 10 megabytes. And then when you run this split command, it splits this 10 MB file into smaller chunks. So you have 10 chunks here named from XAA, XAB up to XAJ. And if we check the file size of these chunks, all of them are going to be 1 MB in size. So that's what we have done here. So next, we need to upload this to our endpoint. So our chunk size is should be 1024 times 1024 bytes. So this is bytes to megabytes. So this is the number of bytes we'll be sending per chunk. So what we are going to do is we are going to loop through all these files and then use our chunk size to calculate the ranges header. So here's what I mean. So index is equals to 0. So you're going to loop. So for I in so it starts from A to J. So A to J do. So our index will be index plus 1. So index plus 1, and then our file name will be, so the file name starts with X and A, and then we append the current value of the index. So it will be XA followed by the index. So actually we can test it from here. We can echo uploading file name. So let's close this loop. and then we can test if our bash script works. So yes, you can see we are now correctly going through all the files from A to J. So let's generate the range headers. So the start header will be the chunk size multiplied by the current index minus 1. So it should start from 0, 1, 2 going forward. And the end chunk should be the start chunk plus the chunk size and then minus 1 since we are indexing from 0. So for the first state here, the start chunk will be the chunk size 104,8576 times the index will be 1 minus 1, so times 0. So the start chunk will be 0. And then the end chunk will be 0 plus the chunk size minus 1. So we'll start from 0 to 104,8575. And then the next one will start from 6 plus the chunk size. So which means our content range header will be, you remember it's bytes, space, then the start, then a dash, then the end, then a forward slash, the total chunks. So the total chunks should be 10 MB. So this is 1 MB, add another 0, becomes 10 MB. So this is what we'll be sending to the API endpoint. So let's print this header so that we can see if we are on the right track. So this is a variable, proceed with the $sign. So let's run the command again. So you can see from the first byte, it's from 0 to 104,575. And then we start from 76 up to the next byte, and then the next one will be 52, then the next one will be 4, then the next one will be, so this is 27, then the next one should be 28, and then finally the last byte will go up to 59. So we can finally send this data to our endpoint. So this will just be a curl request, and then it will be a post request, and then we are sending to localhost. Our port is 3000, upload, and then let's add the headers. So the first header is the content type header. So this will be an upload, so it should be called multi-part form data. So let's not forget to pass the header there. And then the next header will be the chunk size header. What did we call it? Let me see. Yes, so we have the chunk size, the file ID, and the content range header. So chunk size, which is our chunk size variable there. And then another header we need to pass is the file ID, which you can just call the 10mb.txt file. And then another header we need to pass is the content range header. So content range, which is the content range variable. And then finally, we can pass in the file. That will be file is equals to add the file name. So let's at least sleep 1 second between requests just to confirm if the data is being sent correctly. So let's just test this to see if you have made any mistakes, and then you can correct. So bash upload. Now it looks like you haven't started the server. So let's go to the work folder and then run the dev server. Good. So you can now go to our tests folder and then run our upload bash script. Oh, we messed up something real bad. Bash boy is not a constructor. Something is wrong with our server here. So this should not be like this. That should fix it, I think. So let's just clear this console here of all this noise, then restart the server and then try running our script again. So it's receiving the parts, so 0, 1, 2, 3. It looks like all the parts have been uploaded. That's a good thing. So let's check the file system. So the files are in the temp directory. Then the file, remember we are naming it according to the file name, and then we have the 0, 1, 2, 3, 4, 2, 9. So these are the 10 parts that are being uploaded. So let's confirm that these are the correct sizes. So they should be in the temp folder. Okay, let's list the files and see if the file sizes are good. So you can see all the file sizes are 1 MB. So that's a good thing. So let's get back to implementing our code. So we have verified that we are uploading all the parts correctly. So once complete, combine the chunks into one file, move the file to the upload folder, and then delete the chunks. So this is what you're left with. So we should do that here. So after we upload the chunk, we should check if that was the last chunk. So the last part is where the size of the content range equals to the end of that range plus 1. Remember that everything is 0 indexed. So we are moving from 0 going onwards. So our last byte will be 59 instead of 60. So to get if we are at the end, we just add 1 to that last byte. So if this is the last part, let's get all the total paths. So total paths should be the total bytes divided by the chunk size. And then the file paths will be us looping through the value of the total paths and then pushing the path for that part. So this will be an array of strings containing the path to those files. And then our destination file path will be the uploads folder, and the file will be named the file ID. That is a value that will pass into the file ID header. So for this case here, it will be with the file ID should be 10mb.txt, so the same file that you're uploading. So let's also make sure that this exists before we continue. So if it doesn't exist, we have to create it. So what's the next step? We actually need to pass all these files into the destination file path. So that means we need to create an output stream for the destination path, and then go through each of the file paths, read them, and then pipe that stream to the output stream. And then once we finish writing to the output file, we should be able to delete the temporary directory, which will also delete all the temp files. That should successfully merge all the parts of the file. So which means we should send this OK message. So if we are on the last part, we should send the OK message after we have completed the file upload, or when you are still uploading. So that should take care of all the cases that we wanted to cover in this upload. So let's test this bit of spaghetti code. So we need to go to the test folder, should be in the tests directory, and then we need to run our upload script. Okay, so it has completed uploading. So let's confirm if everything works. Okay, so looks like it's not detecting correctly if you're at the last file. Let's double check it. So what we can do is let's just confirm if the correct value is being printed here. So you could also print the range and then run the same command so that we can monitor the range that is being sent over. So for the last part, so the end is 59 and the total is 60. So this looks okay. Okay, so we are using the wrong property here. Should be range.total, not range.size. So let's try sending back the data again. Oh, we have a memory leak. There's too many event listeners that you're attaching here. 11 finished listeners added to the right stream. Those should be for the output stream. What we should do is have a way to process these streams one after another, so that if one stream ends, we go to the next, and so on. So what we can do actually is use an external library that handles this sort of thing. So we can use it's called multi-stream. So let's import it. So it should be multi-stream. And then here we could have an array of streams. So an input stream where we map through the file paths and then return a read stream. So this is an array of read streams. The multi-stream will receive this input stream. So this is a combined stream. So all these input streams will be combined into one stream. And then we can now add only one event listener for this one stream. So pipe it to the output stream, and then we can now listen to the end event of this combined stream and then do our cleanup. Also consider that this may fail. So let's add an on error handler that should at least return a 500 error. So I think that should fix our memory leak. So let's go back to the tests directory and run our upload script. So it is done. So let's check if everything is okay. So our temp folder should be cleared, and then the new file should be in our upload folder, which it is. So let's check if our upload folder is okay. So we can check the file size if it's 10 MB. So uploads 10 MB.txt. So looks like the upload was successful. This is the correct file size. So another way we could check for the authenticity of the files is check the MD5 hashes of both files if it's the same value. So MD5 sum should be the uploads 10 MB.txt and also the tests 10 MB.txt. So they should have the same MD5 hash, which they do. So we are combining the parts correctly here. So this is the first step in implementing our upload service. So we have the upload server working, and the client currently is just this bash file that uploads chunks to the endpoint. So the next step is implementing a client in the browser. Hopefully in the next video, we are going to implement the front end. So that should be all. I hope I gave you a small idea on how to do partial uploads. Thank you for watching, and see you in the next video.